Thank you so much for joining this lesson. We'll be discussing Paper 1 Mathematics, Section 1. The 16 marks in Section 1 are usually compulsory. So let's look at the question right from number 1 all the way to number 16. Remember to subscribe, remember to share, and also to invite a friend for this wonderful discussion of the Kisii mock 2025. Simplify number 1. 2 1/4 minus 1 2/3 minus 5/8 of 3, then everything over 1/6 minus -1/3 squared. Let's deal with the numerator first. Yeah, allow me interact with the numerator first. We can make the numbers improper fractions. This is a 9/4 minus 5/3. Then minus, we can now work the off first, whereby we have minus 5/8 of 3, making it 15 out of 8, because off is multiplication. So now we can subtract, because everything is subtraction now. 9/4 minus 5 out of 3, then minus 15/8. This gives us -1 and 7/24. -1 and 7 out of 24. That is all from the numerator, which can be compiled as a mixed number. 24 by 1, then plus 7, that's -31 out of 24. Yeah, that way. Then the denominator now can be sorted. Let's look at the denominator, whereby we have 1 out of 6 minus, whenever we square a negative, it's like multiplying a number by itself. So the negative has to disappear. So -1/3 now becomes +1 out of 9. Then this is equal to 1 out of 6. We subtract 1/9. This gives us 1/18. 1/18. That is the simplified denominator. Let's check now the combined. -31 out of 24 is being divided by 1/18, which now implies that -31 over 24 is being multiplied by 18/1. And what will this give us? -31 over 24 multiplied by 18. This gives us exactly -23 1/4. So this is now the final answer. As we continue working out, you can also put a few things to see whether we are flowing together, just to confirm our accuracy as we continue together. Let's look at number 2. Without using tables or calculator, evaluate the cube root of 1.90 multiplied by 0.032 multiplied by 0.08, then divided by 20 multiplied by 0.0038. Let's work what is under the root sign first, whereby we can make the numbers whole numbers. And how can we make the numerator a whole number? We can consider the number of decimal places. This is 1, then 2, 3, 4, 5, 6. So 1.9 becomes 19, 0.3032 becomes 32, and 0.08 becomes 8 after multiplying by 1 million because of the 6 decimal places. After multiplying by 1 million to cancel all the decimal places. Then on the denominator now, decimal places are 1, 2, 3, 4. There are 4 of them on this term. Therefore, what we're supposed to do is that we also multiply by the million that we multiplied the numerator with, so that the effect is distributed uniformly, such that this remains at 20, This now becomes 38. Then because we were multiplying with 1,000,000, we remain with 100, which is yet to multiply anything that way. Remember, there is the third root at this point. So now we'll be talking about the simplified form of this, whereby 19 gives us 2 here. Then we can talk about by 2, 1, and by 2, 16. By 4, we can have 5. And by 4, we can have 4. That way. Yeah, by 4, we can have 4. So you see, we'll be having 500. Look at this. The third root of. On the numerator, we can talk about 4 multiplied by 8, giving us 32 out of. Okay, there is something which is not yet simplified anyway. 4 is common. Yeah, that is something I've noticed. Then on the denominator, we have 500. What if we divide by 4 through? We'll be having the third root of 8 divided by 125. Yeah, that's way. So we want now to obtain the third root, and we are not supposed to use a calculator or a math table. So allow me work out the numerator first. The third root of 8. So the third root of 8, we factorize first. By 2, we get 4. Then by 2, we get 2. So 8 equals to 2 times 2 times 2. So to find the third root, or rather the cube root, out of every combination of 3 common factors, we pick only 1. So from all these 3 2's, we pick only 1. So the third root of 8 is 2. What about 125? 125 can be simplified by 5. We get 25. And by 5, once again, we get 5. So now this is equal to 5 times 5 times 5. There are again 3 factors which are the same. So we pick only 1 out of the 3 factors. Therefore, now the final answer should be, when we take the third root of 8, which is 2, the third root of 125, which is 5. Yeah, that's it. It's already done. So that is the final answer, number 2. Number 3. And guys, remember to subscribe. Remember also to invite a friend to this wonderful lesson as we prepare for the KCSE 2025. Remember, our consultation line is 0704 15 33 66. Number 3. The sum of the interior angles of a regular polygon is 40 times the size of the exterior angle. Find the number of sides of the polygon. Look at this. The sum of interior angles. You know, sum of interior angles is usually given by 180 into n minus 2. In this case, n is the number of sides, equals to, what is the size of an exterior angle? 360 divided by the number of angles gives us 1 exterior angle. Then now, this sum equals to 40 multiplied by 40 multiplied by, this is 40. So let me put it well. 40 multiplied by the size of an exterior angle. So this is exterior angle, this is term. So now we can now solve it. So we're going to have, let me divide by 20 even, 20 through, so that we get 9 into n minus 2 equals to 2 into 360 over n. So we can open brackets and have 9n minus 18 equals to times 2 becomes 720 over n. So we can multiply by n through to give us 9n squared minus 18n equals to 720. Then we can solve the quadratic equation. Remember, to solve a quadratic equation, you can apply very many methods. You can use the factorization method, the completing square method, the quadratic formula, and all that. Let me use the completing square method this time round. We first divide through by 9, such that we have n squared minus 2n equals to 720 out of 9, giving us 80. So at this point, we can now think about adding a constant. Can think about adding a constant. This is 2n. So we can add a constant to both sides so that the left-hand side is made a perfect square. This constant c is usually given by b out of 2 squared, whereby we shall have negative 2 over 2 squared. So negative 2 divided by 2 gives us negative 1. And when you square negative 1, you just get 1. So we had 1 to both sides. When 1 has been added to both sides now, we can think of factorizing the left-hand side. How do we factorize it? You pick the square root of this part, n. The sign that follows minus the square root of the constant 1 equals to 81. So we have factorized the perfect square on the left-hand side. Then with this, we can now think of taking square root of both sides. Square root of both sides will give us n minus 1 equals to plus or minus 9. Then now we can find n as equal to 9 plus 1 or negative 9 plus 1, giving us 10 or negative 8. And now that we are dealing with the number of sides, then we pick the positive value of n. We cannot have a number of sides which is negative. So that is it. That is it. That is the exact value of n, the number of sides of the polygon. Let me continue reminding learners to make sure that they perfect on the solving of quadratic equations, simultaneous equations, since we find them in application even in topics that are not quadratic equations in nature. Like here we are dealing with angles and polygons. Who would expect the solving of a quadratic equation? Not really. So don't seek the knowledge on quadratic equations so that you expect it to be evaluated directly. Solve the following quadratic equation. Not really. It will just bring itself up. It shall just emerge as you continue working out math. So please get used. Just get used. Number 4, as we check something here, our one-term ahead program from December, from the 10th of November to 12th December, 5 good weeks on Google Meet. Please join our program here. We will be covering 2026 term 1 work. Target groups are the grade 7s, 8s, and 9s, and also the senior school, Form 3 and Form 4 of next year. So we will cover the work for term 1 2026, meaning that those who will join us will report for 2026 term 1 when they are 1 term ahead. So please join our programs. The till number is already attached, and the line for communication is already on the board, 0704 15 3366. Much welcome to our program. So if your teachers, your parents following me, please reach out for more consultations on the same. And if you're a student and you're a candidate, this program is for the continuing students. You can refer learners to us from your school and beyond. Number 4, a farmer has a piece of land measuring 840 meters by 396 meters. He divides it into square plots of equal size. Find the maximum area of one plot. Find the maximum area of one plot. Let us find the dimensions of the square plots into which the particular room or the particular land, which is rectangular in nature, is going to be divided into. We're supposed to know this, that when we are dividing a room, this is a room, measurements of a land, that is land into plots. Then we shall talk about the GCD. For us to get the dimensions of the plot, we find GCD. The plots that we are getting should be divisors of the land that we are dividing. Then there is another setting whereby you are given rectangular tiles to cover a square room. Then the square room's dimension is not given. Tiles to cover a room, a square room. Here we find the LCM. To get the dimensions of the square room, we find LCM simply because the room that we are getting should be a multiple. The dimensions of the room should be a multiple of the measurement of the tile. But in the case that we are given here, the measurement of the tile should be a divisor to the land which is already provided. In this case, we are already given the dimensions of the land, 840 and also 396. So we find the ECD in this case, greatest common divisor for the two dimensions. We can talk of dividing by the least prime factor, which is 2. 840 over 2 gives us 420. 396 divided by 2 gives us 198. Then we proceed to 2 again. 420 by 2 gives us 210. 198 by 2 gives us 99. So you see, 2 cannot divide again because 99 is not an even number. We can talk of 3 now. Dividing 99 by 3 or 210 by 3 gives us 70. Dividing 99 by 3 gives us 33. 33 is a multiple of 3 and 11. And 7 cannot be divided by any. So we don't have any other common factor. So these square plots are measuring the GCD, which is 12 meters. Therefore, area of one plot should be area of the land. Okay. Area of one plot. Okay. Area of one plot. So area of the plot, because it measures 12 by 12, it's squared, 12 by 12, then it should give us 144 meters squared. Some other times you can be told to find the number of plots which were obtained from the subdivision of the land, meaning that you would get the area of the land out of the area of one plot. But in this case, we just want area of the plot, full stop. Nothing more, nothing less. At number 5, a Kenyan businesswoman bought goods from Japan worth 2.95 million yens. On arrival in Kenya, the custom duty of 20% was charged on the value of goods. If the exchange rates were as follows, $1 equals to 118 yens, then $1 equals to 76 Kenya shillings. Calculate the duty paid in Kenya shillings. The custom duty paid in Kenya shillings. So the custom duty is 20% of the goods, 20% of the value of goods. So custom duty shall be 20% of this value of the goods. The business lady had imported 2 out of 100. That is 20 out of 100, sorry. 20 of 100. This multiplies 2,950 thousands, giving us 590,000 yens. But now we need it in Kenya shillings. Kenya shillings is not linked to the Japanese yen. So what do? We first convert the yens to US dollars, whereby we say 118 yens equals 1 US dollar. What about the 590 yens which were charged on these goods? It will be 1 times 590,000 out of 118. What will this give us? exactly 5,000 US dollars. Then now we say 1 US dollar equals to 76,000 or 76 Kenya shillings. What about 5,000 US dollars? Shall be 5,000 multiplied by 76 over 1. So 5,000 by 76 gives us exactly 380 Kenya shillings. Yeah, 380 Kenya shillings. So that is the amount of the custom duty the Kenyan businesswoman was charged. Number 6. Determine the values of x that satisfy the inequalities and show the solution on an upper line. Let's look at this. When it's a compound inequality like this, we first split into simple statements, whereby the first statement runs from the first term up to the term just before the second type of inequalities. So we talk about -3 minus x less than or equal to a third x minus 5. That is the first inequality. Then the other inequality ends. The other inequality starts just after the first inequality all the way to the last term now. So a third x minus 5 greater than 2/3 x minus 6. That way. So now we can simplify these inequalities into very simple statements, whereby we can have it like this. We have 1 and a third x. You know, we are having a third x, then x on the left, which is negative. So the x which is negative on the left goes to the right and becomes positive. It's like x plus a third x now. Then we also take -5 from the left. From the right to the left, sorry, where to be added. -3 plus 5 gives us 2. So here we are talking of this way. Then we can multiply by 3 over 4 by 3 over 4. 2 multiplied by 3 over 4. This gives us 1.5. Yeah, 1.5 like that. So we are having now a simplified first statement. What about on the other side? We can group terms. So 2/3 minus a third. Here we shall have a third x. Then on this side we shall have -5 plus 6, because 6 becomes positive. This shall be +1. Then how do you remain with x here? Multiply by 3 both sides. X is less than 3. If x is less than 3, this statement can also be rewritten that x is greater than 3. Those are two same statements. 3 greater than x, then x less than 3. So now we can come up with a simple statement for the two cases, whereby if x is here now, we can talk about, sorry, this should be the other way around. I think I was emphasizing the wrong thing. Yeah. If 3 is greater than x, then x is less than 3. That way. So we can have 3 there. And on the other side, 1.5. In case you'd been told to state integral values, I know we have been told to state on an upper line, to simplify and show on an upper line, whereby if you were to state integral values between 1.5 and 3, 1.5, though it is inclusive as a limit, it's not an integral value. So we would start from 2, and 2 would become the only integral value. Let's now represent on an upper line. We can have 0, -1. Here we can have the positives 1, 2, 3, 4, like that. So we are starting from 1.5. Here, the mid of 1 and 2, all the way to +3. Because 1.5 is inclusive, we shed that circle there. Then we can now show like that. So that is the indication or the representation on a number line. The representation on a number line. Those who are joining us late, kindly be informed of our programs here. Kindly be informed of our programs here. The one-term ahead program. Look at what you'll be doing over the December holiday, the November holiday, from the 20th of November to the 12th of December via Google Meet. Very interactive. We'll be covering content like content. Teachers of all the subjects will be on board. Please join, refer to your friends who are in lower forms, who are in the junior school. We shall be equipping learners from all the levels. So please welcome, join us, and let us grow our academics. Shifting Grades, the home of academics. At number 7, yeah. At number 7 now, a very good question. Solve for x in 27 power x plus 1 minus 3 power 3x plus 2 minus 400 equals to 4 equals to 86. So how to flow in this one should not bother you so much. We've done very many examples on this, and I hope this one will still be bearable for our case. We can make the composite numbers to the least possible bases. For example, 27 can be re-expressed as 3 power 3. Then already we are having x there, plus 1 using minus 3, 3x plus 2, minus, okay, equals to, we can have it as 486 now on this side. 486 cannot be put to base 3. And for that matter, let's talk about now applying some laws of indices. We know very well that the product law allows us to open the bracket here and have 3x plus 3 minus 3, 3x plus 2 equals to 486. Then we know that when we have a power m multiplied by a power n, this can be solved by just taking the common base, then the powers are added. So now that the powers are added, we can now apply the law in the reverse way, such that we have 3 power 3x multiplied by 3 again, power 3. That's why the powers have been added, minus 3 power 3x multiplied by 3 power 2 equals to 486. Remember, 3 power 3x is appearing twice. So we can let this unknown, 3 power 3x, to be, say, a different unknown, like t. Yeah, choose even t. Then we proceed in the expressions. Now, we're going to talk about 3 power 3 is 27. So 27, the value of t, minus 3 squared here, this is 9, t equals to 486. So this is going to be, when we take 27 and we subtract 9, we are getting 18, t equals to 486. What about the value of t? The value of t shall be 486 out of, which is 27, out of 18, which is 27 that way. So with 27 now, what had we let to be t? 3x had been let to be t, and now we have found that t is 27, so which is 3 power 3. So because the bases are now the same, we can equate the powers. 3x equals to 3. The value of x now becomes 1. Yeah, the value of x is equivalent to 1. Very simple. Let's look at number 8. A very good question. Number 8. Very, very good question. And guys, remember to load airtime to your phones using our simple model here, whereby you just go to the Lipa na M-Pesa. On the M-Pesa menu, the pay bill number is already attached, 737356. Then the account number is the particular phone number that you're purchasing the airtime. Could be the Airtel line, the Safaricom line, the Telcom line, You just feed it as the account number. Then from there, you can now proceed with the transaction. You receive your airtime instantly. You can also do the same for a friend. So please master the pay bill number 737356. A businessman bought 2 bags of maize at the same price. So the buying price of the bag, 2 bags of maize at the same time, okay? On arrival at his business premises, he discovered that one was of higher quality than the other. He sold the higher quality bag of maize at 10.40 and made a profit. He made a loss by selling the low quality bag of maize at 880. Given that the profit is 3 times the loss, calculate the buying price. Let's let the buying price. We can let the buying price to be X, any unknown. For instance, the X that you have picked. I want us to analyze the question keenly. Remember, the bags have been bought both at X. Then now, how do we get profit? Selling price minus buying price. It was bought at X. How about loss? The loss is equal to the buying price minus the selling price. You know, a loss is when you sell at a smaller value than you bought. Therefore, there is a relation now between the profit made and the loss made. He made a loss by selling the low quality bag of maize at 880 shillings, given that the profit is 3 times the loss. This profit equals to 3 times the loss that way. We can now find the buying price, which is X. Mm-hmm. 880 multiplied by 3 gives us 2640. 2640. Then from here, we can now group terms. Whereby on the right-hand side, we can have positive 4x, 3x plus the x which is on the left. Then now we'll be having 1040 plus 2640. Yeah, we get 3680. Then now we can get the value of x as, when we divide through by 4, 920. So the buying price is 920 Kenya shillings. 920 Kenya shillings. A very good question. Very good question. Thought-provoking, actually. And I like it. I hope you also like it. Remember, our consultation line remains 07 04 15 33 66, and this is also our M-Pesa line. So kindly use it effectively. Number 9. The figure below shows triangle PQR in which PR equals to 12, then T is a point on PR such that TR equals to 4. TR equals to 4 centimeters. Then ST is parallel to the baseline, which is QR. If the area of triangle PQR, the bigger one, is 336 square centimeters, find the area of the quadrilateral QRTS. So this is not, again, a simple question. People are supposed to analyze it with a lot of carefulness. PR is equal to 12. Then TR equals to 4, meaning that P to T equals to 8 then. This is 8. So if we apply similarities and enlargements, then we can say the slanting edge of the bigger triangle out of the slanting edge of the smaller triangle. This is equal to what? it will give us what you call area scale factor. 12 over 8. This gives us 1.5 linear scale factor. This is our linear scale factor. Now, with linear scale factor, we can talk about area scale factor, which is supposed to be linear scale factor squared, and that is 2.25. That is the area scale factor. Now, we are given area of the larger triangle, which means we can find area of the smaller triangle. So area of smaller triangle shall be 336 out of 225. If we had area of the smaller, for us to get area of the bigger, we would have multiplied. But now that we want area of the smaller, then we divide by the scale factor. 336 divided by this, we get 149 and a third square centimeters. 149 and a third square centimeters. With these, ladies and gentlemen, we can now talk about the contralateral. So for the contralateral QRTS, we talk about the total area minus 149 and a third. So 336 minus what we are having here, 186 and 2/3 square centimeters. That is now the area of the contralateral given this one now. Remember, we could not use similarities and enlargement for the contralateral because what we have related are triangles, and the triangles are the ones that are similar. So that's why similarities and enlargements remained on the triangles only. Yeah, to remain on the triangles only. Look at number 10, ladies and gentlemen. A very good question here. In number 10, we are told that two buses, A and B, leaves the same station. Bus A heads due east, while bus B due north. The northbound bus traveled at 10 kilometers per hour faster than the eastbound bus. After 5 hours, the two buses were 250 kilometers apart. Calculate the speed of the northbound bus. This one is a very serious setting. Let's say from the same station, one bus goes to the north, another bus goes to east that way. There's a bus going to that direction from the same point here. Then after 5 hours, so let's say we have covered 5 hours, then we'll be having the distance here between them. The direct distance, which is now the hypotenuse here, is supposed to be 250 after 5 hours. So we can calculate using expressions first, the distance covered by the north bus. You know, distance is given by speed times time. So the one going to the north is moving at, the one going to the east can have a speed of x, meaning that the one going to the north will have a speed of x plus 10 because it's 10 kilometers per hour faster. Meaning that if we are calculating distances now, towards the east, the distance should be 5 hours times x, the speed. Then the other one, it has still taken 5 hours. So it will be x plus 10 also times 5 hours. So now we can use Pythagoras theorem whereby we say 5x plus 50 squared plus 5x also squared equals to 250 squared. Pythagoras theorem, so that you may find the values of x. So 5x squared gives us 25 x squared plus 2 times 5 times 50, giving us 500 plus 2500 plus 25 x squared equals to 250 also squared. So when we square 250, ladies and gentlemen, I'm getting 625,000. Yeah, 625,000. 625,000 like that. So now we can arrange the equation, grouping terms together here and there. Yeah, so that you may see how to get the values of x. 50 x squared, so after combining. And then now we can talk about this being equal to 625. We subtract 2500 and we also subtract 500. This gives us 59,500. X squared shall be equal to, we divide through by 50 first, get 1190. Yeah, 1190. Then the value of x shall be the square root now, giving us 34.50 kilometers per hour. 34.50 kilometers per hour. Yeah, kilometers per hour. So that is it. That is it. I hope the brackets were properly opened. The north bars now. We note that is the value of x. So the north bars now, the northbound bars will be when we add 10 here to give us 44.50 meters per hour. Yeah, that way. I hope the brackets were properly opened. I just hope we didn't make any mistake in that. Yeah. Okay, so we can now proceed to number 11. Given that the tan of x equals to 12 over 5, it has been given as a fraction. Find the value of sine x plus 2 cosine of x divided by 1 minus the sine of x. Okay, so we're supposed to now express this one. First, we integrate the provided information in a triangle. So we assume that our x is a point at this point. When we talk about tangent, it means if the right angle is here, tangent is given by opposite length out of adjacent length. So what is the opposite length in this case? The opposite length is given by opposite, then the adjacent one is 5. From this, we can apply Pythagoras theorem so that you may know the hypotenuse also. So we talk about hypotenuse being 12 squared plus 5 squared. Then now we take the square root of 169, giving us 13. So this side is 13 units. Huh? I hope you got me at that point. So we first fill the triangle so that we can extract sine of x. So now replacing in the expression, sine x shall be, sine is given by opposite length of hypotenuse, 12 over 13, plus 2 multiplied by cosine of x. Cosine is adjacent over hypotenuse. Adjacent length is 5, hypotenuse is 13. Then out of 1 minus the sine of x. You know, sine of x is already 12 over 13 that way. So a mark goes to that right substitution. 12 over 13 plus 10 over 13, then out of 1 minus 12 over 13. You know, this gives us 1 over 13. Yeah, 1 over 13. Then from here, let's talk about 12 out of 13 plus 10 over 13, giving us 1 and 9 over 13. Yeah, 1 and 9 over 13. 1 and 9 over 13. Then this is being divided by 1 over 13, which means times 13 over 1. So when I multiply this by 13, I'm getting exactly 22. Exactly 22. So the answer is 22. The answer in this case is 22. Without the use of a calculator, without the use of a math table, we have found the expression. We can now proceed. We can proceed. This is number 12. Use reciprocal tables to find the value of 1 divided by 0.325. That is reciprocal tables. Hence, evaluate the square root of, is that the square root? Yeah. The square root of 0.00125. Everything divided by 0.325. We all know the reciprocal tables, and we know their unique features. So that is what you'll be accessing this evening. Let me just open the reciprocal tables. But before we go to the table, can we talk about 1 into the reciprocal? We write in standard form first, 3.25 times 10 to the power of -1. So it will be 1 multiplied by this reciprocal of 3.25 shall be read from the tables, while it should be known that the reciprocal of 10 power 1, 10 power -1 is 10 power. Now we reverse the power. If it was 10 power 1, it could have become 10 power negative. If it was 10 power -2, it could have become 10 squared. So we just reverse the sign on the power. Yeah, the sign on the power. Very simple. So we can now go to the reciprocal tables. The reciprocal tables. Yeah, let me see this. So we go to the reciprocals part. The reciprocal tables. Is it after roots or just before roots? What I know is that they are neighbors. Yeah, reciprocals. 3.25. Is it so? 3.25, yeah. So 3.2, then 5. 3.25. So 3.2 is it? .2 like that. That is the row. Then we identify the column with 5. Yeah, the column with 5. So there we find it is 0.3077. 3077. That way. That is now the reciprocal, meaning that when we compute this, it shall be 3.077 that way. So we have the reciprocal already. We already have the reciprocal. From there, let's now talk about working out what had been provided there. It means now we are supposed to find the square root of 0.000125, and we multiply it by 3.077, because 1 out of is already implied here. Therefore, we have already worked out that part. How can we get square roots? Again, from the math tables. We need to talk about now standard form. 1.25 times 10 to the power of negative 4. Is that negative 4? Yes. 1, 2, 3, 4. Exactly. So now this should be obtained from the table. Square root of 1.25. 1.25 square roots. 1.25. So 1.25. 1.2, then the column with 5. Yeah. So it should be 1.1180. 1.1180 times 10 power negative 2. Now for the 10 power, we take the half of the power to obtain square root. Then now this should multiply 3.077 to give us the final answer. This then shall be 1.118 times 3.077, giving us 3.44. Yeah. 3.44 times 10 to the power of negative 2. This is already right. Standard form is okay. An expression is okay in its standard form. Then now we can talk about 0.0344. That 0.0344 properly expressed. Are we at number 13 now? Yes. This is an interesting question. Very interesting. Simplify completely. 2x squared minus 98 divided by 3x squared minus 16x minus 35, then divided by x plus 7 all over 3x plus 5. Let's deal with the first term, whereby there is a numerator and a denominator. This is going to be, we factor out 2, x squared minus 49, meaning that we can still have the 2 and have this one now simplified, because it's a difference of 2 squares. So we have simplified the numerator. Let's check now. Let's check. Let's check now the denominator. Tell them to simplify it. So at this point, we are now having the denominator, which is quadratic in nature, with a product of 3 multiplied by negative 35. That is negative 105. Then a sum of the value at b, which is negative 16. Now, let's look at the two factors which, when multiplied, they give us negative 105. When added, they give us negative 16. So we can factorize 105 by 3. Let's take 105 divided by 3, giving us 35. Then by 5, we get 7, like that. So we can now look at the pairings. The pairings that will give us a negative 16. Negative 16. What if we take 21 and 5? That is 7 by 3 and 5 alone. Then we give this one a negative. Negative 21 multiplied by 5. That's okay. Negative 105. The negative 21 plus 5. That gives us negative 16. Then we are right to use negative 21 and 5. Negative 21 and 5. So now we are having on the denominator part now. This is the numerator. Let's check the denominator. 3x squared minus, instead of 16, 21x plus 5x minus 35. So from the first pair, or from the first two, you can factor out 3x, remaining with x minus 7. Then from the other pair, we remain with x minus 7 again. So simplified, we will have from the brackets x minus 7, and outside the bracket 3x plus 5. So with this now, we can combine the numerator and the denominator. The numerator and the denominator. The numerator and the denominator should be combined so that we first finish up with the first term here. Therefore, we'll be having, remember the numerator simplified to give us 2x minus 7. Then now we are having x plus 7 like that. This now is divided by, from the denominator, we have x minus 7, then 3x plus 5, meaning that the common factors can cancel out. And when they cancel out, this one cancels like that, so that we have 2 into x plus 7 out of 3x plus 5. Then dividing by x plus 7, dividing by x plus 7 over 3x plus 5 means multiplying by 3x, the reciprocal now, plus 5 out of x plus 7. Meaning that now we can simplify common factors like this and this, and this and this. So the final answer is exactly 2. Final answer is exactly 2. We proceed to number 14. Number 14, we are told that Fatuma is now 3 times as old as her brother and 4 times as old as her son. Look at that statement. Fatuma is now 3 times as old as her brother and 4 times as old as her son. 8 years from now, Fatuma will be 12 years more than the sum of the age of the brother and the son. Find Fatuma's present age. Now we are talking about Fatuma. Let's start by expressing Fatuma's age. Fatuma is led to be X. Then currently, Fatuma is 3 times as old as her brother. Okay. Or we can let the brother to be X. Yeah? The brother to be X. Let's have the brother to Fatuma being X. We can get a better expression that way. So the brother to Fatuma is X. So that Fatuma is now taking 3 times as old. Then what else are we told? And 4 times as old as her son. What about the son? Fatuma is 4 times as old as her son. So to get son's age, then we have to take Fatuma's age and we divide it by 4. That way. Divide it by 4. Those are the current ages. With current age like that, we can talk about 8 years' time now. 8 years' time. 8 years' time. Let me express that. 8 years' time. The bro is going to have added 8 years. Fatuma will also add 8 years. And the son to Fatuma will also add 8 years. That is 8 years now. Now, what is the relation in their ages? 8 years from now, Fatuma will be 12 years more than the sum. So Fatuma, which is 3x plus 8, she's going to be 12 years more. 12 years more. So that means when we take Fatuma's age and we subtract the sum of son and brother, we will get 12. I hope that statement is well understood and interpreted. When we take Fatuma's age, 8 years from now, then we are saying that Fatuma will be 12 years more than the sum of the age of the brother and the son. Brother and the son. So that's a very clear interpretation. 3x plus 8 minus 3/4 x minus 8 minus x minus 8 equals to 12. So now we can group terms. We can group terms and simplify. 3 minus 3/4. That is the terms with x minus again 1, giving us 1.25 x. This is equal to, we are having 12 on the right. So we add 8, we add again 8, and we subtract 8, yeah, to give us 20. So what will be the value of x at this point? What will be the value of x? The value of x shall be, we divide 20 by 1.25. This is going to give us exactly 16. So x is 16 years. Remember, that's the age of the brother to Fatuma. What about Fatuma herself? Fatuma is going to be 3 multiplied by 16, giving us 48. Yeah, giving us 48 years of age. 48 years of age. Let's check number 15 now. We are told that we express 3.5 recurring in the form. So we are simply converting a fraction. We are simply converting a recurring fraction into a recurring decimal into a fraction. Therefore, we shall have, we can start with R being let to be 3.5 and 5 is recurring like that. What about an R, which is going to be 3.555. You see now, on the decimal parts, we can now subtract and get 0, 0. So now we can subtract at that point. 10R minus R is 9R. Then 35 minus 3 gives us 32. So we can get the value of R, which is 32 out of 9. Now, 32 over 9 is going to be 3 and 5 over 9. 3 and 5 out of 9. You see now, we are having the fraction, which is given as a mixed number at that point. Number 16, whereby we are now winding up. Look at number 16. The diagram below shows the histogram showing marks scored in a certain test. We have frequency density. Then we have the classes there, of course, showing the marks. Draw a frequency distribution table for the data. If the first class has a frequency of 8, the first class has a frequency of 8. Remember, we are having the frequency density here, which is given by frequency out of class width. Frequency of a class width. Therefore, we have a class width which can already be established according to the limits which have been plotted. So from 9.5 all the way back to 4.5, we have a class width of 5, right? Therefore, frequency of 8 in the first class is given by a width of 5 times a frequency density of 4. frequency density of 4, which must have been multiplied by a certain constant. Multiplied by a certain constant. Because naturally, we should be able to say that frequency of a class wing, frequency of a class wing, that is 8/5 equals to 1.6. So 4 equals to 1.6. So what has multiplied 1.6 to give us 4? Something has multiplied 1.6, a certain constant, has multiplied 1.6 to give us 4. Something has multiplied, or rather, we can say, we need to multiply frequency. Let me just simplify it. In other words, we can say this. For us to get frequency, we need class width multiplied by the frequency density. Then we will say that in this case now, the class width is 5 and the frequency density is 4. But now, these two have been divided by a certain factor so that they give us 8. So what is this factor which has been involved? This factor which divides here is going to be, the value of C shall be, we take 8. Okay, we take 20 divided by 8. 20 out of 8 gives us 2.5. So we'll be applying 2.5 across. 2.5 across for us to get frequencies. Every frequency will be given by class width times frequency density out of 2.5. Yeah, that way. So now let's get to the table, whereby there is a few things here that we're supposed to understand. One is that for us to get what we are calling a histogram, for us to get a histogram, we should know that class boundaries has been plotted. So for us to get the class limits now, we should know that this boundary represents a class starting with 5 all the way to a class ending with 9. Then their frequency is given as 8. Now in the next class, the class begins from 10 all the way to 19, meaning that the class width is 10. So the frequency there will be given by class width of 10 times a frequency density according to the height of 6 out of 2.5. So what will be the frequency in the next class? 10 multiplied by 6 out of 2.5. This is 24. So the frequency is 24. That way. The other class is starting from 20 all the way to 39, meaning that the interval there is 10. So we talk of a width of 10 times a frequency density, which is the height of 2. Then this has to be divided by 2.5. So 20 over 2.5, giving us a frequency of 8 once again. And finally, from 40 all the way to 49. Then the width there is 10. Yeah, the class width is 10. So we talk about 10 multiplied by the height, which is the frequency density. The height there is exactly 4. Then for us to get frequency, we divide by 2.5. This is equal to 10 times 4 divided by 2.5. This is going to be exactly 16. Exactly 16. So now we've come up with the frequency distribution table as demanded by the examiner. Frequency distribution table. So you're supposed to be very careful. More so, when one of the frequencies has been determined, when a frequency has been determined, you should be in a position to know what is happening. So that's the paper. Thank you so much for following. See you next time. Thank you.